Okay. After let's start designing the bandpass splitter. So the first one you need to edit this value to 3.55 as the requirement of the design. And other values actually you can let it default as we are not required, or you can use the values I use same as me. Uh, yes, you only need to change the values. Change this value. Other values you can let it default, or choose your own favorite value. Uh, so for the convenience, I change to a set of default values here, and we need terminals. Uh, you can always search the components like this. We need to use a component called MCFIL. You can search it in parts or find it in transmission lines, uh, uh, microstrip line, and you can find there's a component called MCFIL. Yes, and the place as we are going to design a order 4 amplifier, we need to place 5 of them. This is covered in your lectures, and the beginning transmission line is for the connection. You need it is required in the further uh layout design part. So we place two microstrip line here. This is called MLIN. You can also find it. Then we connect all of the components. Oh, I need to use the line tools. Actually, this is the geometry of the filter. It is very straightforward, and now we need to add some variables. Variables are important as it can helps you with the optimization of its performance. So what we need to define is firstly the length of these 5 coupled microstrip line, and the width of course the width of the 5 microstrip lines, and the beginning and the ending microstrip line we also need to optimize it. Then we need to uh, define the variables called L1, and you can firstly cut the default X and click here, and adding more variables you can just type change the names here and click on add. Then we can add the variables we need all together in this window. We also need to define a variable called S1, S2, and S3. Yes, to set variables, you need to find a component called var. You can search var and place one here. Double click it, you can edit the variables. Of course, to start simulation, you need to place a component called S parameters. Yes. Actually, we have placed the components of the filters, and the next step you need to do is calculation. As in this part of design, there is a lot of formulas we need to use. So we need to first calculate the the parameters of these five couple line couple line couple line microstrip lines, and then we can use the line calculation tools, which is located at here to help you further finalize your design. And I will give an the example in 4G gigahertz. Firstly, we need to write down the five equations we need. And the values for the prototypes I have given, you can also find it in reading materials. And so in the we can firstly go to the line calculation function. Oh, it is already opened, and go to the type called MCLIN. Yes, this is the coupled line microstrip line, and we can find that we need is the even mode impedance and the old mode impedance. and these two values can be given by the two equations. So the first step is actually we need to calculate ZOE1, ZOE2 for the five, going to the ZOE5 for the five coupled line microstrip line, and similarly ZOO1, ZOO2 to ZOO5. And after finishing the calculations, we can import them to the line calculation tool, and we can calculate its physical size of the coupled line. Uh, to save time, I will just show you the calculation of the first one, and to calculate the first one, we need to calculate the J1 first. The J1 we can get it uh from this equation. We need to calculate J1 first, and from this equation we can calculate J1, and the delta here is the bandwidth, which is 10%, and so J1 we can calculate as this. You can use your own calculator to calculate, and the Z0 is 50 ohm. So all the values here we have known, and the G1 is 1.6703. Oh, okay. For this one, they you no need to change. No need to change. Just input the even mode impedance and the odd mode impedance. The Z0 will be automatically calculated from these two equations. And if you change Z0, the other values will also change. So after you have input these three parameters, you can click on synthesize, and it will calculate the physical values of it. And this is the physical size of the first coupled line. We can now we can change it with the parameters we have just defined. Be careful to the unit. You need to set it to millimeters. And this is S1. This is L1. Click on apply, and similarly for this couple line, we also need to set it. There is a trick that this geometry is a symmetry geometry. So for the number four coupled line and number five coupled line, actually, you no need to define more variables called s. You can set this S4 to S2, and similarly for this one, uh, we set W4 and L4 first, and we can set it later. For the first one, we also change it to the variables we have just defined. And then we need to type in the result we have just calculated. We open these windows, and this is W1. We can copy and paste here. This is S1. So, so for other couple lines, you need to calculate by yourself, and it is different with different center frequencies. Now I will, for quicker analysis, I will type in the following variables I have calculated. For these variables, you also need to enable the turning function similarly as first one. We are going to optimize it later, and you can also turn on the optimization function. And in this lab tutorial, I will introduce the optimization function of ADS. Click. Oh, this one. For the optimization, you need to define the minimum value and the maximum value. You can actually use the value here, and change it later if it does not meet your requirements.